I'm Dr. Greg Ellis. How many of us know the cause of most diseases? How many people in the medical community know the cause of most diseases? The way you hear them talk, you would think that we don't know much about disease causation. Simple things like heart disease, we think that's because cholesterol impacted upon the arteries, clogged them all up, and created other kinds of problems. But that's not the case. It's not the truth of the matter. I want to introduce the idea that we do know the cause of most diseases. And it's based on three ideas that are interrelated with one another. First is the glycation theory of disease and aging. Second is the insulin theory of aging. And then third is the mitochondrial theory of aging. So you can see aging is involved in all of them. So the disease process increases with increasing age. And that becomes the problem. Now I'm going to read a couple things to make my point. Two strong correlates of aging are mitochondrial dysfunction and accumulation of altered proteins. They're the structural proteins inside your cells. They become altered and affected. I'm going to tie all these three things together. Aging is a complex physiological phenomenon, and several different theories have been elaborated about its cause. Among such theories, the mitochondrial theory of aging describes the decline of mitochondrial function as one of the driving forces for the process itself. Next, neurodegenerative disorders such as Alzheimer's and Parkinson's share common features like mitochondrial dysfunction. So that tells us that we know what these neurodegenerative diseases are being caused by. And the medical profession keeps saying we don't really have any idea what's causing that. We don't know. We do know. More on the decline in mitochondrial function and how that plays a role in the aging process. These are statements right out of research papers. I've got a whole pile of research papers just on this one topic of aging and disease. We've learned a lot more about mitochondria. There's a process that goes on inside the cell called autophagy. And the process of autophagy is such that it destroys damaged mitochondria. Now, mitochondria have a half-life of about 10 to 25 days. That means their lifespan is about 20 to 50 days. If they become severely damaged, the cell actually eats them, degrades them, breaks them into their parts, and those parts can be used again to reassemble new mitochondria. So you're constantly rebuilding yourself. However, if you end up with a lot of mitochondria that are resistant to getting eaten, and that's what happens sometimes in the aging process. They get really stiff, and they resist the cellular mechanisms by which they break apart. These mitochondria are really dangerous because they're no longer processing energy as fuel, and that makes them become a real burden for the cell. So it's important to understand that the disease process is fairly well understood. A great deal of research has gone into this over many decades, and we understand that it's tied very tightly with the aging process, and this in turn is tied tightly with the mitochondria. The glycation issue is that glucose coming from the carbohydrates you eat and its immediate byproducts as it gets processed by the cell will cause a glycation. It means it binds to the proteins. Glucose binds to proteins. So mitochondria are made up of proteins, and glucose binds to these proteins, and it changes their shape. It makes them damaged, causes them to release reactive oxygen species, which causes inflammation and other damage to the cell. It's a real nasty mess. So that's the process of disease and aging, and we understand it fairly well. So to suggest that we don't know what's causing disease is just simply not true. We do. So I'm going to go on and have other parts in this set of videos to describe some what I think are logical expositions about what we can do to prevent disease and prevent aging. I'm Dr. Greg Ellis.